Morning grade sixes, and welcome to your mathematics lesson for today, brought to you by WorksheetCloud.com. I hope you guys are well after a long weekend. Looking forward to the short 3-day week, and I hope you're ready to sink your teeth into some more mathematics. Just a reminder about the email address on your screen, grade6@WorksheetCloud.com. Please send me any questions about the work that we've covered, or perhaps there's something that we haven't covered that you're really unsure of that you'd like me to have a look at. And again, that's not a problem. Okay, so today we continue with polygons and quadrilaterals. On either side of that, we've got our starters and our finishers. So without any further ado, let's have a look at your starter for the day. So by now you know that you should be using your math skills to find out the value of each symbol. And don't forget the question mark at the end. Right, off you go. The first thing I'm going to look at is the bicycle signs. And I know that 192 must be divided by 6 because there's 6 signs there. If I do that, I get 32. So 2 of those signs is worth 64. So if I add 64 3 times, okay, 60, 60, 60 is 180. And then 4 plus 4 plus 4 is 12, and the 180 plus the 12 gives me 192. Okay, then I know that I've got 32, and I need to add that to 254. So what number multiplied by itself gives me 254? So what is the square root of 254? And that's 16 multiplied by 16. So 16 times 16, 254, add the 32 is 288, okay. Now I know I need to multiply something by 16, okay. So what multiplied by 16 gives me 576, so then I would have done 576 divided by 16, and let's talk through that quickly. I don't have to do a long division sum for this. I can halve both numbers. Okay, to 288 divided by 8. Sorry, that shouldn't be an 18. That should be a 16. Okay, divide that by 8. All right. I can go further and halve both of them again. So what's 288 halved is 144 divided by 4. Okay, I can go another step and say half of 44 is 72 divided by 2, and you're quite correct in saying that that's 36. Okay, so I know that the traffic cones must equal 36, so what multiplied by itself gives me 36, and yes, that's quite correct. That's going to be 6 multiplied by 6 times 16 is 576. So I just want to emphasize that point, that when you want to do a division sum, remember that if both the dividend and the divisor, so the dividend would have been 576 and the divisor would have been 16, if they're both positive, I can halve them, okay, and I can keep halving them until the question becomes really straightforward. As long as you're doing the same thing to both 576 and to 16, your answer will remain the same. Okay, and now that's all that's left for me to do is to plug in my values. So I know that's 32. Okay, I know that one mobile phone or parking device or whatever it is 16. So 2 of them must be 32. And then I multiply by 6. Okay, and you should know that I do the multiplication first. Okay, so 32 times 6 is 192, and then add the 32 and you get 224. Okay, well done if you worked through that, and if you managed to get it. I thought that was a little bit trickier than some of the ones we've had before. Okay, your mental maths questions for today. Sophie's home is about 850 meters from school. How far in kilometers does she walk in a week of 5 days? Making one return journey each day. So read the question carefully there. Question 2, by how many millimeters is 780 millimeters greater than 0.5 meters? Number 3, write in kilometers per hour a speed of 18 kilometers in 10 minutes. Number 4, 4 3/4 times 8. Number 5, the angles in a triangle add up to what? And I've squeezed in an extra question for you today. I wanted to recap long division, 3,888 divided by 12. Give it a shot. Look at number 1. So if Sophie lives 850 meters from school and she makes one return journey each day, then each day she must be walking 850 meters times 2, which is 1,700 meters. Okay, and if she does that for 5 days, I must multiply that by 5 days. Okay, 1,000 times 5 is 5,000. 700 times 5 is 3,500, and that gives me 8,500 meters. And if you wanted to put that into kilometers, 8,5 kilometers. Okay, you could have also said 850 multiplied by 5 first, okay, and then doubled it. All right, that would have given you the same answer. So if you had said 850 multiplied by 5, then I would have said 800 times 5 is 4,000, plus 5 times 50 is 250, so that equals 4,250, okay? And now I've got the 5 days, but I need to double it, all right? And then that's going to give me 8,500 meters, which is 8,5 kilometers. Okay, right, so that's your answer for question number 1. 2 ways to work that out. Okay, let's go to question number 2. By how many millimeters is 780 millimeters greater than 0.5 meters? And we need to realize that 0.5 meters is 50 centimeters, and 50 centimeters is 500 millimeters. So I'm just looking at your conversions there, and then subtract 780 and 500, and you're going to be left with 280 millimeters. Okay? Okay, good. And then question 3, write in kilometers per hour a speed of 18 kilometers in 10 minutes. Okay, so 18 kilometers in 10 minutes. All right, I know that there's 60 minutes in an hour. Okay, so to get from 10 to 60, I multiply by 6. So I must multiply 18 by 6, and 18 times 6 is 108 kilometers in 60 minutes, so 108 kilometers per hour. Okay. Then multiplication of fractions and a whole number. Okay, so just to recap that, change it to improper fraction first, which is 19 over 4. 4 times 4 is 16, plus the 3 is 19. And we said when we did multiplication of fractions that it's beneficial to have 2 fractions. So 8 is the same as 8 over 1. Now I can say 19 times 8 over 4 times 1. Okay. 8 times 10 is 80, plus 9 times 8 is 72. So it's 152 over 4. Right. And then I can work it out by either halving. Okay, so half of 152 is 76 over 2, and then 76 divided by 2 is going to give you 38. Okay, so 4 3/4 times 8 is 38. Alternatively, we could have already simplified in the question. So we know that 4 goes into 4 once and into 8 twice. Okay, so I simplified diagonally there. Now all I've got to do is 19 times 2 equals 38. and denominator is 1 times 1, which we know is 1, and anything over 1 is itself. Okay, so both ways you get the same answer. Question 5, we need to remember that the sum of the angles in a triangle add up to 180 degrees. Always, doesn't matter what the triangle looks like, but the 3 angles in a triangle always add up to 180. And your last question, 3,888 divided by 12. Okay, so again here you'll have some options. You could halve 3,888. Okay, so half 3,000 is 1,500. That's if you want to do it in steps. Half 888 is 444. Okay, so together 1,944, and now I'd need to divide that by 6. Okay, again, both the dividend and the divisor are even. Okay, so I would go and halve it again. So half of 1,900 is going to give me 950, and half of 44 is 22, so that's going to give me 972 divided by 3. Okay, and now I've converted my long division sum into a short division sum. Okay, now I know that 900 can be divided by 300 times. Okay, and I know that 72 can be divided by 3 because I know my rules of divisibility. 7 plus 2 is 9, so therefore 72, and 9 is divisible by 3, so therefore 72 is divisible by 3. So if 900 is divisible by 300 times, and 72 is divisible by 24 times, my answer is 324. So I haven't really had to do anything too hectic there, I don't think. I've just halved numbers and then divided by 3. If you had done the long division method and kept it as 3,888 divided by 12, okay, first thing I might have done is 12 times 10 equals 120. 12 times 20 equals 240. Okay, so I'm aware that I'm well away from it. Okay, if I had said 12 times 30 gives me 360. Okay, but now I know that 12 times 300 equals 3,600. Okay, I'm another 288 away from 3,888. Okay, so if I look at these two, if I add 240 and 3,600 together, I get 3,840. I know that I'm 48 away from 3,888. And I know that 12 goes into 48 4 times. Okay, so 12 goes into 3,888 20. 320. And the 4. And that gives me my 324. So again, you would have got the same answer as we got before, but they're just different methods. But I would choose the halving method because both numbers were even. Okay. Right. I hope you guys worked through those questions and managed to get them correct and remembered past principles that we've learned. Let's see how you guys get on with the rest of the lesson. Okay, guys. So today we look at quadrilaterals. So quadrilaterals are any four-sided shape. They are also named according to their properties. So these are some properties that quadrilaterals might have. They might have equal and or parallel sides. They might have equal angles, right angles, diagonals that bisect each other. And bisect means to cut in half. Okay. diagonals that are at right angles. Okay, so when diagonals bisect each other, they bisect each other at 90 degrees. There could be line symmetry, also known as reflective symmetry. Okay, and that is when if you fold something in half, the one half fits perfectly on top of the other half, and also rotational symmetry, and we'll get into rotational symmetry in a few lessons' time. Okay, so first thing I've got for you is a little polygon pop quiz. Okay, and you need to identify the following shapes based on the characteristics given. So your first one, I have 4 equal sides and 4 equal angles. Quite correct, a square. Number 2, I'm a 3-sided polygon. I have 2 equal sides and angles. And you should have remembered this from a previous lesson. It's an isosceles triangle. Third one, I have 4 sides and 4 angles, but I only have 1 pair of parallel lines. That would have been your trapezium. Your parallel lines are the sides at the top and the bottom. Next one, I'm a quadrilateral. Both pairs of opposite sides are parallel. And here you've got a choice. You could have either said a rhombus or a parallelogram. Okay? And we could say square and rectangle because they also have opposite sides or both pairs that are parallel. And your last question is, I'm a 5-sided polygon, and yes, your name is a pentagon. Okay, good. So the first shape we're going to look at is a parallelogram, and quite often described as a rectangle that's been pushed over onto its side. But the opposite sides are equal, so the same as a rectangle. And we indicate those equal sides by drawing those stripes. Okay, so the sides that have 1 stripe in them are equal, and the sides that have 2 stripes in them are equal. And then we have signs for parallel lines. And again, notice that the top and the bottom sides have 1 arrowhead to show that those two are parallel, and the left and the right hand sides have 2 arrowheads to show that they are parallel. Then a parallelogram also has diagonals. Diagonals go from one corner to the opposite corner as indicated by the dotted lines, and they bisect each other. And as I said, we were going to look at rotational symmetry. So rotational symmetry is how many times can I turn that object in a 360-degree rotation, and during that rotation the parallelogram fits exactly onto its original shape, and that would have been 2. So don't stress if you're not sure about rotational symmetry. I'm planning on covering that in a few lessons time. Okay, your next one is a rhombus. So a rhombus is very similar to a parallelogram. It's also got 4 sides. The opposite sides are also parallel. But in a rhombus, all 4 sides are equal. So it shares a similarity with a square in that all 4 sides are equal and opposite sides are parallel. Okay. The diagonals of a rhombus bisect each other at 90 degrees. So when those diagonals bisect at the center of the rhombus, they create 90-degree angles. There are 2 lines of symmetry in a rhombus, so you could fold that rhombus shape on its vertical or horizontal diagonal, and the 2 halves would end up on top of each other, and it has a rotational symmetry order of 2. Okay, so that's a rhombus. Then we have a rectangle, and we know that a rectangle has opposite sides of equal length, indicated by the stripes. Opposite sides are also parallel, and there are 4 right angles, okay, in the corners of the rectangle, and it has 2 lines of symmetry. A square, 4 equal sides, 4 right angles, opposite sides are parallel, and it has 4 lines of symmetry, okay, vertical, horizontal, and then also diagonal, and it has a rotational symmetry order of 4. Right, the trapezium. the trapezium has only got one pair of opposite sides that are parallel, indicated with the arrowheads. Sorry, and there's some questions for you. Can a trapezium have any lines of symmetry, and can it have rotational symmetry? So let's have a look. So first of all, we have an isosceles trapezium. Again, two sides or two opposite non-parallel sides are the same length, and it's got one pair of parallel sides. There are your equal sides. There are the diagonals of an isosceles trapezium that are of equal length. There's one line of symmetry, so therefore it does have symmetry as indicated by the first question. So we've just seen in an isosceles trapezium that there is a line of symmetry, which is great. So yes to the first question. And then rotational symmetry, I will explain to you as when we get into rotational symmetry of all shapes. Right, another quadrilateral is a kite. Okay, quite often I have students calling this a diamond. Okay, so please, it's a kite, it's not a diamond. And here you see the word adjacent. Okay, and adjacent means two sides that share a common vertex or a common corner. Okay, so those two sides are adjacent to each other. Okay, and they are of equal length. And then you've got the two longer sides that are adjacent to each other that are also of equal length. Diagonals of a kite cross at right angles. Notice we don't use the word bisect. Bisect means cut in half, and you can see that those diagonals do not cut each other in half, so they cross, and it has one line of symmetry, and that is that horizontal line. Okay. And then an arrowhead, or also called a delta, is also quadrilateral. It's got four corners. It has two pairs of adjacent sides of equal length and one interior angle more than 180 degrees. So there are the equal length adjacent sides, and you can see the interior angle, which is greater than 180 degrees, which is actually a reflex angle. And interestingly enough, it still has diagonals. However, the horizontal diagonal is outside of the shape, but that horizontal diagonal and the vertical diagonal, they do cross at right angles. Again, notice the word cross and not bisect. When they bisect, they cut each other in half. And one line of symmetry. Okay. Next, I'm going to show you the quadrilateral family tree. So this is how quadrilaterals are related. Okay, kite is related to a quadrilateral purely because it's got four sides, and a delta is related to a kite. Then we have the parallelogram is related to the rectangle, the square, and the rhombus, and that's four sides. Opposite sides are equal, opposite sides are parallel. So they share very similar characteristics. And then you have the quadrilateral being related to the trapezium and the isosceles trapezium. And just a reminder that the isosceles trapezium is the only one that has symmetry. Okay, so guess the shape. Can you identify the shape from its properties? Let's see how well you have been listening. It's a quadrilateral. Its diagonals cross at right angles. It has one vertical line of symmetry. It has two pairs of adjacent sides of equal length. Okay. None of its interior angles are more than 180 degrees. So I'll give you a couple seconds to think about that. Your shape is a kite. So first you can see it's a quadrilateral with four sides. The diagonals cross at right angles, as we mentioned earlier. There's one vertical line of symmetry. Okay, so there's a point that's arguable there because the current state that the kite is in at the moment, it would be a horizontal line of symmetry. Okay, going from left to right. Okay. It has two pairs of adjacent sides of equal length, as discussed earlier. and none of its interior angles are 180 degrees. Okay, second one, quadrilateral, four-sided shape. Diagonals are equal. One line of symmetry, which is vertical, and again, dependent on how the shape is drawn, or what plane the shape is drawn in. One pair of parallel sides, so immediately it rules out your rectangle, rhombus, parallelogram, and square. One pair of opposite non-parallel sides of the same length, okay? And I'll give you a couple seconds. Your shape is an isosceles, trapezium, and remember it's the only trapezium that has, in this case, one vertical line of symmetry holds true. Okay, so that's your quadrilaterals for the day, possibly a recap from previous work, but important that we get that done before we move on to more geometry and more shapes. So your brain bender today, the total of this puzzle is 714. So you need to figure out what numbers go in to the symbols. So for example, 5 multiplied by the cupcake is going to give you the cookie. The candy floss multiplied by the cupcake is going to give you the muffin. 5 times 2 gives you the coffee. And the candy floss times 2 is going to give you the 4 on the bottom right corner. Okay guys, go and work that out and we'll have a look at it on the Jamboard. So I'm just going to work out what I know. I know that 5 times 2 is 10, so the coffee is 10. I know that the candy floss times 2 must be 4, so the candy floss is going to be equal to 2. Okay, so 2 times 2 gives me that 4. Alright, so 10 and 4 add up to 14, and I know that my total is 714. So the cookie and the muffin must give me 700. So I'm going to look at 100 for the cupcake. So 5 times 100 gives me 500 for the cookie, and 2 times 100 gives me 200 for the muffin. So if I add those together, I get 700, add the 14, and I get 714. Okay? Okay, so there is your 24 challenge for the day. And by now you know that you should use all 4 numbers and any of the operational signs or combination of the operational signs to get to the answer of 24. So for example, for the first card, I would have said 6 plus 4 plus 6 plus 8. So I can use all addition, and that's going to give me an answer of 24. But perhaps there's a different way that you guys can work it out, or there's more than one way to get the answer of 24, sorry. And yeah, I'm interested to hear if you guys can find multiple ways of getting the same answer. Okay, grade 6s, that's all we've got time for today. Please feel free to go back through this lesson and have a listen to the characteristics of quadrilaterals. It's really important that you can identify them based on their characteristics. And remember, these are building blocks for geometry and theories that you're going to be working on when you're older. So it's really important for you to understand these concepts and to keep them fresh in your memory for when you are older. Right, have a great day, and we'll catch up with you tomorrow. All the best.